Question 121. What key metrics would you track to assess the efficiency of an academic production pipeline, and how would you prioritize them? In assessing an academic production pipeline, I would track metrics such as processing time for submissions, error rates in publication, and user satisfaction scores. Prioritizing these metrics involves understanding the impact on the overall workflow. For instance, high error rates could indicate systemic issues that need immediate attention, while processing time might reflect operational bottlenecks. Additionally, user satisfaction helps gauge the effectiveness of the pipeline from the end-user perspective, ensuring that improvements align with user needs. Question 122. Describe a situation where you had to resolve a complex data inconsistency issue within an academic database. What steps did you take? In a previous role, I encountered a data inconsistency where publication dates were mismatched in our database. I first traced the issue by examining logs and querying related tables. After identifying the root cause, incorrect data entry following a migration, I implemented validation rules to prevent future discrepancies. I also collaborated with the data entry team to correct existing errors and designed a reconciliation process to ensure ongoing accuracy. This multifaceted approach not only resolved the immediate issue, but also improved the overall reliability of our data management practices. Question 123. How do you ensure that your academic production processes are compliant with institutional policies and external regulations? Compliance is critical in academic production. I ensure adherence by regularly reviewing institutional policies and relevant external regulations. This involves conducting periodic audits of our processes and documentation to identify compliance gaps. I also implement training sessions for team members to keep them informed about compliance requirements. Additionally, I establish a feedback loop with legal and compliance teams, ensuring that any changes in regulations are swiftly integrated into our workflows. This proactive approach minimizes risks and fosters a culture of accountability. Question 124. Can you explain how continuous integration, continuous deployment, CCD, principles apply to academic production environments? CCD principles in academic production environments facilitate rapid and reliable delivery of updates to databases and applications. By automating testing and deployment processes, we can ensure that changes to academic content or software are integrated seamlessly, reducing the risk of errors. For instance, I would set up automated tests for new features in our submission system to verify functionality before deployment. This allows for quicker iterations based on feedback while maintaining the integrity of the production environment. Ultimately, CCD enhances collaboration among teams and accelerates the publication process without sacrificing quality. Question 125. What tools do you prefer for data visualization in academic analysis, and why? I prefer using Tableau and Power BI for data visualization in academic analysis due to their powerful capabilities and user-friendly interfaces. Tableau excels at creating complex visualizations with an intuitive drag-and-drop functionality, making it accessible for non-technical stakeholders. Power BI integrates seamlessly with Microsoft products, allowing for efficient data manipulation and sharing within organizations. Both tools offer robust analytical features, enabling me to extract insights from large datasets effectively. By presenting data visually, I can communicate findings more clearly to diverse audiences, enhancing decision-making processes within academic settings. Question 126. Describe your experience with cloud services. How do you leverage them in academic production? I have extensive experience with cloud services like AWS and Azure in academic production. I leverage cloud infrastructure to ensure scalable data storage and computing capabilities, which are vital for handling large datasets from research projects. For instance, I utilize AWS S3 for storing raw data and AWS Lambda for processing it in a serverless environment. This approach reduces costs and improves efficiency, allowing researchers to focus more on analysis rather than infrastructure management. Additionally, I implement data security measures in the cloud, ensuring compliance with privacy regulations while maintaining accessibility for authorized users. Question 127. How would you approach the integration of new software tools in an existing academic production workflow? Integrating new software tools requires a structured approach. First, I would assess our current workflow to identify pain points that the new tool could address. After selecting the appropriate software, I would pilot it with a small team to gather feedback and identify integration challenges. Training sessions would be essential to ensure all users are comfortable with the new tool. Once implemented, I would monitor its impact on workflow efficiency and gather ongoing feedback for continuous improvement. This iterative process ensures that the integration enhances productivity without disrupting existing processes. Question 128. What strategies would you employ to troubleshoot a performance issue in an academic web application? When troubleshooting a performance issue in an academic web application, I would begin with systematic monitoring using tools like New Relic or Google Analytics to pinpoint where delays occur. I would analyze server response times, database queries, and user interactions to identify bottlenecks. After isolating the issue, such as slow database queries, I would optimize them by indexing or rewriting them for efficiency. I would also consider load testing to simulate high traffic and assess performance under stress. Finally, I would document the troubleshooting process to inform future maintenance and enhance our knowledge base for similar issues. Question 129. How do you handle version control in collaborative academic projects, especially when dealing with sensitive data? In collaborative academic projects, I utilize Git for version control, enabling effective management of changes and contributions. I implement branching strategies, where each team member works on separate branches to avoid conflicts. For sensitive data, I ensure that repositories are private and access is restricted to authorized personnel only. Additionally, I employ encryption for sensitive files and establish clear guidelines for data handling and sharing. This approach not only protects sensitive information but also facilitates collaboration, as team members can track changes and revert to previous versions if necessary, ensuring data integrity throughout the project lifecycle. Question 130. What role does user feedback play in your workflow as an academic production analyst, and how do you collect it? User feedback is crucial for refining academic production processes. I collect it through surveys, focus groups, and direct interviews with faculty, researchers, and students. By employing tools like Google Forms or SurveyMonkey, I can gather structured feedback on user experiences with our systems. Analyzing this feedback allows me to identify common issues or areas for improvement. I prioritize actionable insights and collaborate with stakeholders to implement changes that enhance user satisfaction. This iterative feedback loop not only improves existing workflows, but also fosters a culture of continuous improvement and user-centric design in academic production. Welcome to CloudRoar CSPM, your intelligent cloud security posture management platform. In today's hybrid and multi-cloud world, maintaining visibility and control across AWS, Azure, and Google Cloud can be complex. CloudRoar CSPM simplifies that by continuously scanning all your cloud accounts, configurations, and workloads. Our platform automatically detects misconfigurations, compliance violations, and potential security risks before they become incidents. CloudRoar CSPM provides clear, actionable insights mapped to major frameworks like SIS, NIST, and ISO standards, helping your teams remediate faster and stay audit-ready at all times. Strengthen your security posture, achieve continuous compliance, and take control of your multi-cloud environment with CloudRoar CSPM, security that's smart, scalable, and proactive. Introducing CloudRoar Cost Optimization, your unified platform for smarter cloud spending across AWS, Azure, and Google Cloud. Cloud costs can grow silently, but CloudRoar gives you full visibility and control. Our engine continuously analyzes usage patterns, instance sizing, and idle resources to uncover hidden savings. With intelligent recommendations powered by real-time data, CloudRoar helps you right-size resources, eliminate waste, and maximize return on every dollar spent in the cloud. Get detailed reports, actionable cost insights, and automation that ensures continuous optimization without compromising performance. Optimize confidently, scale efficiently, and make every cloud dollar count with CloudRoar Cost Optimization. Efficiency meets intelligence. Welcome to CloudRoar CSPM, your intelligent cloud security posture management platform. In today's hybrid and multi-cloud world, maintaining visibility and control across AWS, Azure, and Google Cloud can be complex. CloudRoar CSPM simplifies that by continuously scanning all your cloud accounts, configurations, and workloads. Our platform automatically detects misconfigurations, compliance violations, and potential security risks before they become incidents. CloudRoar CSPM provides clear, actionable insights mapped to major frameworks like SIS, NIST, and ISO standards, helping your teams remediate faster and stay audit-ready at all times. Strengthen your security posture, achieve continuous compliance, and take control of your multi-cloud environment with CloudRoar CSPM, security that's smart, scalable, and proactive.